Hello, 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 hello. Let's go. Yo, Blue. What's up, what's up? Welcome. Alright, so, yeah, I'm been looking at the optimization for the collision system. And I think I've come to the conclusion that perhaps the issue is not the quad tree itself. Well, there are some issues with the quad tree, but I would say that what we tried yesterday was basically trying to optimize the quad tree more to be able to do the things we want to do. So essentially, I think that when we have like this large map with a lot of ground entities, hello penguin, and those ground entities are actually like quite large, like some actually span through the whole map, so those will be checked every time. A lot of the ground entities are like checked maybe unnecessarily many times, so when you have a lot of them entities being spawned, you get a lot more checks. And so I think what we want to do is we want to implement two separate collision checks, basically. So one is going to be for static objects which are not moving, and they are basically going to be, I mean, they essentially, well, not really static maybe, but more the tiles, the tile based like background, because the tiles can be very much improved, like the efficiency of checking against the tiles, instead of having them be like entities that are added to the quad tree and then very inefficiently like spread around the quad tree. What we can do is we can implement a specific algorithm specifically for a grid tile based map, and then use that as a broad face collision, so for the ground specifically. So we essentially have two types of collision algorithms. So we'll have one for the tiles and then one for everything else, like dynamic objects, or they could be static as well, but essentially anything that is not based on the tile system. So that is an idea, and that will significantly improve the collision detection part, because most of the entities right now are the ground tiles, and they are kind of optimized a little bit, like we're merging like adjacent ground tiles so that they are not like a bunch of different entities. We are kind of merging them together, but horizontally, but it ends up being worse when they are span the entire map and they're being like orphaned. So so that is one idea, that improvement that we could do. That would require us to build this whole new algorithm for a broad face of the kind of grid spatial whatever algorithm there. Another thing we could do also is like improving the quad tree a little bit more. The recent actually change that I did here for for filtering turned out to be not great. And actually, if we spawn at the village, whoops, actually I forgot I had this like nice shortcut there. If we spawn at the village, You can see everything is fine and dandy here. We move over to this side. Now we get some kind of weird bug here. I'm not sure why this is happening. And it only happens on like this specific coordinate, I guess. If we jump up here, it's fine. It's only specifically on this level here. And possibly one more level or several levels. But essentially, it's like a band of... like it works down here. It works fine down here. But then, like up here, it's mayhem. So there's something going on with the collision algorithm here that just doesn't work. So I'm thinking of backtracking the filtering thing, because that also did not really help with anything, basically. So it's an interesting idea, but I think that we could probably try to implement it better. I'm not sure if the vectorization works properly either. So yeah. I'm thinking just scrapping this whole thing, to be honest. Like, we could keep... I mean, we're keeping the changes we did to the array list themselves. So that was a good thing that we did. But I think that... yeah, this whole thing here... we'll just skip. And now index is not used, but let's keep it around, because I think it's good to have anyway. And then here we simply don't populate this. We don't do anything with the filter. We don't calculate the result. Also, a thing here is like the calculate result. Like, we don't really need to do that every single frame. It only needs to be done if something changed, like if you add an entity, if you change the setting of an entity. However, I was like, I don't want to build a infrastructure for that, so I'm just like calculating each result every frame. But this is not what is taking time. Like, what is taking time is actually just going through all the intersections and stuff. So there we go. Now, okay, so we've got rid of that. Now, I'm not sure if that was the reason why the game like was acting up or whatever. But let's see. We'll build this, and I will try to go over here if it still has the weird issue. So now we don't get the issue anymore. So there was something weird going on with the filter, I think, that made it not work. But however, we do need to add this check back here now. Oh, we already... oh, so we have this check as well. Okay, well, we want to have this check anyway, so whatever. Okay, and so that could be one thing that we could focus on this time, like trying to implement this new algorithm, like this new thing, and move all of the tiles over to that new system. And that will also make it so that we don't need to merge the tiles. We simply have them in that grid, spatial grid system instead. And so then essentially you want to do... I'm just thinking about how we want to divide up the collisions checks. Because most things, like essentially almost all things, are it's just gonna collide against the ground. There are some things that are dynamic that we also want to check for collisions for. However, I think that, I mean, possibly. I mean, yeah, we could like optimize that as well, but it's like, I think it's only things that are like solid and that you have enabled collisions for. Then it's the only things you need to check collision against. There are some things that can move that you can collide with, but I was thinking, like, could we avoid doing the whole dynamic quad tree altogether for if we don't actually need to check for any of those? Or we could try to insert less entities in there. I mean, it's gonna be way less now if we move all the ground out of there. That's gonna be a lot of things we just move out from there. But we do need to implement this whole new algorithm. But I think it's gonna improve a lot. It's gonna make it so we don't even need to think about collision system ever again, probably. So yeah, that's basically the idea. Because I've been also testing here, like, it's not, I don't think it's like that a bunch of gems are spawning at the same place. I think the issue, because if we add let's add a bunch of these chests here, and we'll go down and open them. Okay, you can see that the FPS does drop a lot though. However, I think it's just because that we have a lot of ground entities that we are also constantly checking against. Alright, but if we make, let's say let's just make a new scene here. And I'm just gonna, this is just a basic scene here. I mean, we could add these to make it a little bit more believable here. And maybe one platform up here, 2 platforms. So we have a little bit, for all these are gonna become, this is gonna become like 4 entities down here that span the whole thing, and then we have 2 entities up here. That's what this is gonna like result in. Okay, so, and then we're gonna add some chests that we can spawn things with. And then we have the player here. All right. Okay, the FPS actually does drop. Maybe it's because I'm running OBS at the same time or something like that. But it does actually drop quite a bit. Because I was testing this earlier and it didn't actually drop that much. Or it didn't actually drop at all if we just ran this in a test environment. Well, what if we, let's say we remove most of this, see how much this will affect the thing. Okay, it actually reduces it quite a lot. Well, interesting. Okay, so it's still still is a lot of things. It's just that, yeah, they're getting like brute forced. I think they are like brute forced against each other. Maybe what we could do, we could add a counter that counts. So first, so I want to add a counter that counts how many checks we do. Essentially this. I think we can do something like this. I'm just curious to see how many checks are being done. And then I'm just gonna go here and say before we do this, the tree intersection. Where did it go? Intersection check count. Is my LSP not working, or like what is happening? I couldn't find a string. Oh, right. I need to like oh man. You know what? Let's just do this. We'll put you as a field. Oh, it was even not even in there. Okay. Oh, this is in shape. Yeah, I'm not looking here. All right. So there's the struct. I'm confused. Use of undeclared identifier. Right. I mean, it's not used in that many places. It's only here. And then I want to... We don't need to do it every time though. It's gonna be a lot of logs. It's gonna be like 8. If I put the log here, it's gonna be like 8 per frame. Every frame is 10 milliseconds. I mean, sure, why not? Actually, let's only do it here. We need to actually have it there. So now let's see, we need to build. Chest is open. 2 are open. Okay. So we should have gotten a bunch of these. And here we can see in the last place we have like 2,200 checks. And yeah, it probably just... That's where I think I picked one up. So it basically doubled. I mean, yeah, it was like a linear. I was expecting more of a like an like a square increase. We're doing 123 intersection counts just with the player and the 1 ground tile. That does not seem right. Hang on. I'm gonna do a new, very simple test scene here. I'm gonna set the tile map size to be like 4 by 17, fine. Okay. And we're just gonna have 1 ground tile and only the player. Where's the scene here? Sorry, this one, and then you have to start. Okay, how many checks? Wait, what the hell? No, this one. Okay. It does like 81 checks. What? Excuse me. Something is very, very strange here. because we go in, there should only be like 2. Okay. I mean, okay. So there are like... Okay, there are more entities. Actually, there's these thin walls here. They are blocking the exits here, so that you can't like run off and jump down. So they are actually extra. They always span across the whole thing. You can see here. Also, they are always orphaned. So, I mean, yeah, they are spanning against the whole thing, but anyway, and then we got the ground. We've got, what is that? I'm not sure what that is. Yeah, there's something here. I'm not sure what that is, what it spans. There's the ground, there's the player. The player is actually this little box here. But then there's also things moving along with the player, which you have like, I think the player has, it consists of like 4 different entities, or maybe 5. It's the player itself, like the main body. And then it's like the sword. The arm is like a separate thing, I think, and then the shield, and then something else, which I don't remember. But there are a couple of different things, so we can like show like different animations at the same time, basically. But they are basically not really supposed to be part of the collision system, really. It's just the main player body that's supposed to be part of that. So let's count this. We have like 1, 2, 3, and I'm not sure what this is, so I'm gonna say it's either 4 or 5. Let's do 5 for being conservative. 5, 6, 7, 8. I'm pretty sure the player has like 4 or 5. So let's say, so 5, 6, 7, 8, 9, 10. Actually, 9 is probably better because there's 9. There's 81. That's 9 squared. However, we also have the quadrants, so those also count to be intersected with. We have the boundary, we have the, you know, these quadrants here. Now this ground is like orphaned, basically, so we check against that always. Because it's not part of the boundary here. Well, it is part of the boundary, but it's not part of this here. I guess the player entities here, they are checked against each other as well. Hang on, but I think the shield and stuff like that, I'm not sure if that actually has a rigid body though. Let me double check here. I just think that there's like way too many checks going on here. Player. Let's see, where is that happening? I think it's like init player, no? We have like the load game or load scene something somewhere. Here, load scene, create player. So we have like all of these things. However,
these do not really need to have rigid bodies. I think they only have that so that we can like, so that we have like an easy way of like you know, setting a position for them. Yeah, so we're essentially just adding this. It's not solid, it's static, so it's not even, you know, it's not even supposed to be part of the collision system. So anything that is not solid is not even supposed to be able to be collided with. So that's the thing. Maybe we should just have a filter as well on the things that we pass into the thing. Let's actually check this. So what we send in is basically all of the rigid bodies. If we could instead filter those based on the solid, that's gonna be a lot better. I mean, we could just try to do it here. This is gonna happen every like 8 times per frame, so it's not really a good place to put it, but I'm just gonna try to make a filter here. Actually, what we could do is probably, let's see, we'll put this, I mean, could we add a filter to the view? Is there a way to filter the view? I'll just add this filtered bodies, array list of actually it's gonna be entities. Also convention. Right. When is this called? Oh, the OR tree. Okay. Update positions. Do we have like a separate step? That we do one time. We have the body container start physics frame. We don't have the collision container. I'll just do that. We don't care about the end frame, but I guess we can add one as well. So now you have start frame. Now this is where we should populate filter bodies, or update filter bodies. End frame, we don't really need to do anything. Okay, but now we have that. So populate filter bodies. So essentially we just loop through all of these entities. Actually, what if we do raw? No, we need the entity anyway, and we'll get the body. Actually, we could, I think get const is probably faster, and then Or is it faster? I don't know. Anyway, and then, because this copies the whole thing. I don't know. We get that. Then we say if. So we essentially want to calculate if the body should even be part of the simulation here. So filter body. So actually first we need to clear this retaining capacity. And we have some like, let's just call filter body body there. And if that is true, we will keep it, I think. So then we append the entity there. There we go. And then we have filter body. Okay. So this is going to be part of the collision if it's not solid, basically. Or I mean, yeah, if it's solid, then it's going to be part. If it's not solid, we don't want to have it here. Now you can also optimize this by not having to do this every frame. Instead of doing this every frame, you would like do it once, and then every time you add an entity, we will like add it with like in an optimized way. You just need to worry about that specific entity. Like, is the new entity part of the collision system or not? If it is part of the collision system, we add it. If it's not, we don't. If you remove an entity, we need to also remove it from here. If you let's say, what other things? Yeah, if you update the solid state of a body, it should like propagate through to update it here directly, or be put into some list or something that then will get updated. So we don't need to like repopulate this every frame. But I don't think this will take so much time. I mean, it's once per frame, but it's like ON per body. So I don't think it's gonna take that much time. But you know, you can optimize this, but I don't think it's gonna be like a huge amount of optimization given. But let's just try this here. So filter body, expected type T, found pointer, right. Actually, you know what, let's just get const, whatever, because Zig promises that it will like try to optimize. If you send this in and you don't actually modify it or anything, it might actually send it by reference and not copy the thing. So it doesn't really matter because we're only looking at the data anyway. I think so anyway. Okay. So there we go. That's essentially it. And right, so now we have the filter bodies. Now when we run the place where we are looking at the thing here, instead of doing self-view data, we are going to say intersecting candidates is not going to be this, it's going to be filter bodies items. And then over here we have the entity keys. Yeah, so this should all work out, I think. All right. So this will this probably like improve things a little bit. We'll see. Okay. Okay, now we're down to 16. So that's a lot of checks being removed there. And I mean, we probably do want to check for correctness, although, yeah, okay. Actually, let's do this test now. Let's test this again here. I need to remove the save file here. So these chests are... Okay, it's still significantly... I notice immediately, like significantly anyway, that these are... So before we got like 2,000 something checks. Let's see how many we got now. Okay, so it wasn't really that much of a difference, but I was like worried there that we had some kind of weird error in our algorithm that made it so that it was like, I don't know, way more than it should be. But it turns out that it was just, yeah, I mean, we do get like 42 checks. I want to check like the chest. Right. Hitbox static true. This is not supposed to be solid, so I'm just gonna check if the chests are part of this. Solid options is solid is true. What? No, the chest should be false. It's not supposed to collide with anything. Sorry, false. Okay, so now we don't. I see. I can't activate it now. We have like activate. Activation target. Find nearest. Oh. Okay. So find nearest actually is using the quad tree, right? The thing is, we do want to add the entity to the quad tree. It's just that we don't want it to. We don't want to report. Okay, this is such a micro optimization anyway, so I'm just gonna put this back. The issue is that find nearest will only find things that are in the quad tree, and since we don't actually add it to the quad tree, we can't find it. The thing though, I mean, maybe we need to have like different lists. Maybe we could like add entities after the fact, and then we add entities after the fact, after we've done all the physics collision, so that we can find things in it. So we can add the non-solid ones after, but we don't include them in like the physics simulation. That could be one thing here. But this is as I said, this is like a pretty like micro optimization, I would say. It doesn't even reduce the number. I think more what we need to do is figure out how we can reduce the number of the checks, because it's like 2,000 checks. I mean, that's almost like the number of gems squared. There's like 30 gems being spawned. It's not much off like the number of gems squared. Especially since they don't need to check against each other. The gems don't need to check against other gems. Which is why if we separate the ground from everything else, then we will reduce the amount of checks significantly. But let's do like this. So I'm gonna do, and actually we could do this in end frame actually. So we have all the filtered bodies. Let's also add another one, which is the cold bodies, or whatever we want to call them. And we'll add this to the cold bodies if it's not part. And then in the end frame, when we've resolved all the actual collisions stuff, we will add these actually into the tree. And I have to remember if we have like an insert. Because I don't actually remember. I think we can just insert them straight up like this. Yeah, we're using this in this one. But this is the old one. Populate page. I think insert should probably work fine. It's using the same kind of idea. So insert into page. Yeah, let's just use insert. However, this is like an index. Okay. This is meant to be used where, like, in a different way, really here. Like, you have an index into the entries. So actually we need to like append and what we do then is we say entries, entry values need to be extended, which is a problem because I'm not even sure if we no, we are copying this. Okay, yeah, we're duplicating. Okay, so we have control over that. Actually, we don't want to append one by one. We want to just append a bunch. Append slice. Yeah. So this would be new entries and ABBs. There we go. So then U would be concat concatenate those. Problem though, the ABBs also need to be concatenated, I think. So that is like pre-copy. Let's see. Yeah, this also needs to be appended. So let's see. Here's like pre-copy, it just copies over. And let's just see where this is happening here. Yeah, we simply wait, we append on this one. I think this is like looking into the entries. This is like one part of that whole large buffer. I'm pretty sure. I'm confused. This is an array. The thing is, like, when we add more things, like when we populate the tree, we actually pre-calculate how many pages are needed and like allocate everything up front that we need in order to accommodate for all of the things. But now if we want to add a bunch of new things in, that could change, like depending on how many, like let's say we add like as many entries as we had before, then we need to double the amount of pages or something, or yeah. So this is a little bit rigid, I would say. Man, I thought for sure we had like a way to add a new entity, but maybe we don't. I don't think we have. It's just that we have a bunch of... These are all like internals here. Okay. So let's see. Okay. Append slice. Alright, so I don't think we can do this right now without doing a whole bunch of more stuff. I'm just gonna backtrack this part here. Let's just... whatever. Let's just put this back here. So... I mean, one thing that we could do is we could like just rebuild the quad tree. So we essentially have two different quad trees. We have one that is only used for the physics simulation, and then one that is used for finding nearby bodies. I think that if you have like... No. Yeah. So actually... we don't really need cold bodies then. We can just add everything in back in then. Instead. So where is... Right, it's only the R tree that supports insert entry, right? Intersecting, no. Where do we actually build it? So this is where we build a thing. So we essentially need to just call this function with the other candidates, basically. But now we need a boundary as well. Well, we could actually the boundary. Do we have the boundary here? Do you have the boundary? Populate. I guess we could just go to the root node, grab the ABB from that. We need IO. Oh no, we actually just need to call populate. We don't need IO. We need allocator, context boundary, entries. We just need to do that, I think. Okay. So we're populating the tree twice now, but the population part does not actually take that long. Thank you, piano. So now that problem should be fixed, hopefully. So essentially, start of the physics frame, we start with physics update. We filter the bodies. We run the collision system on only the things that are right, so now we can open the chests. Did I change this back? No, solid is false. Okay. Cool. Is this your game? Yes. Thank you. Thank you so much. All right, I think, okay, so we did actually reduce the amount of checks now by like, I don't know, 300-400. That's actually quite good. Okay. So we simply filter the bodies before like this. That was way faster actually than doing it the other way. Okay, cool. Basically want to move this here. Populate tree with all entities. Wait, did I remove Nightbot? Or why is it Nightbot working? Oh, there you go. I mean, there's only like 2 commands. Discord and GitHub. I'm kind of boring. Sorry. But if you have suggestions, I can add more commands. I don't know. Okay, so start frame, end frame. So there we go. Now, what the hell did I think about? Okay. So we have the idea remaining that we could build another algorithm that only includes the ground tiles. So basically the tile map is going to be put into like a hash, spatial hash, whatever, grid hash thing. And then we're gonna be able to query that for ground collisions instead of having the ground be actual entities in a quad tree, because it's very unoptimized for that specific use case, especially since our ground is spanning the whole the whole tree. So Yeah. Oops, I didn't want to do that. Wait, let me check something here. So if we go over here now, okay, it's the FPS is a tiny bit better. So it's like it's a tiny bit better, but it's still pretty unacceptable. So if I can explain this here. So basically what you see here is we've got these all of these ground tiles are basically merged into horizontal kind of rectangles like this. So every like adjacent tile is put into a horizontal entity that is then inserted into the quad tree. But instead of doing that, what we want to have is like a grid based algorithm. So because, and also especially since all of our tiles are basically there's no tile that is like that has like a slope or anything like that. It's going to be very old school Castlevania kind of style tiles where it's like everything is a block. You know, Super Mario, everything is a block basically. So we don't, it's not going to be super you don't even need like further detailed blocks checks, although you can have that. You can use the spatial grid as a hash as a broad face collision check, so we know which tiles we need to check further. So first you do a broad check to say, okay, which where is the player right now? What kind of tiles are around the player that we need to check for further, you know, collision checks. But really, since they are going to be very simple tiles, they are simply always going to be these blocks. We could skip that check and just check directly against, like, are we colliding with any solid tiles, basically. So I'm not sure exactly how to implement that. I mean, I could think of a very naive way is to just have each tile be a cell in a 2D array, and then you would simply convert, like, try to convert the ABB of the player into like a kind of a boundary in that map, and try to figure out, okay, which tiles do I need to kind of check for solidness. So checking all of those tiles for solidness. If any of those are solid, then we have a collision with that tile. The only thing I'm thinking about that is, like, there's a lot of data, I guess, to be stored. I mean, it's not that much. How large is this map, really? This map is like, if we open this, 251 by 31. And they only need to be bits, so it's like on or off. So that's 7,781. So around 8K bits. That's just, you know, 8. I mean, it's not even 8 kilobytes for this one map that's going to be stored. So it's not a lot of data, actually. We could just store it like that. Although, I mean, there might be more optimized ways of storing the data, which also allows for a more optimized algorithm. I don't know, actually. Yeah, maybe we can do a quick search for that. So tile tile grid spatial hash Okay, there was basically nothing there. It's perfect spatial hashing. Okay, this looks a lot more complicated than I need. Like, I'm not interested in these super advanced mathematical things. It's just a very, very simple... Okay, so this person is feeling silly, asking questions, but there are a bunch of examples or tutorials on how to implement a spatial hash. Oh my god, this fucking... I'll be back. Yeah, the article, I mean, it's surely interesting. I'm just not interested in that advanced stuff right now. I just want to have a super simple lattice, 2D lattice based thing. Implement a special hash grid cell based partitioning, preferably C++ and stack. I have no idea how to tackle this problem. So well, that's easy to do. Okay, which I'm sure is true if you've seen another implementation or others. I mean, you know, the thing is, like, yes, you can try to do it yourself. You can come up with a solution to the problem, which is usually how I want to do things. It's just that I also want to search now to see, okay, are there any ideas floating around on how to do this efficiently or whatever? Like, is there like this is the canonical algorithm for this specific type? You know, the Super Mario Brothers tile-based map. Like, is there like just a super easy implementation for that? That's what I was looking for. I mean, yes, I could go ahead and try to kind of come up with my own solution, which is also fun. That we could do. I just want to, but I right now I just want to have something that works. that's the thing as well. Like, I just want to get some kind of idea on, okay, is there a more optimized way of doing it? Like, let's say I implement this and it doesn't turn out well, then I've basically, like, I don't want to spend the time to find that out. Basically, I just want to see, okay, is there a nice solution? Like, sometimes I do want to do that. Sometimes I do want to do that for fun. But right now, I'm just in the mood for just finding something that actually works right now. But I guess if people are saying this, then maybe, you know, maybe you can do the naive approach or something. Instead of chord trees, I like there are spatial areas of a game which is a very large world. I think in that it probably wouldn't even have to account for size of mirror points as the type of game mine is. As the type of game mine is, that isn't that big of an issue. And if it is, I could always add that. To do a basic spatial hash, slightly more complicated for instance, you need to generate a broad discrete grid location for any game location. This might be as easy as converting float positions to ints, or taking ints positions and dividing them all by 64 or some other constant. The idea there is to create a single discrete location most nearby objects will map to. For instance, if divided by 64, both objects at blah 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 will be mapped with cell to 1. You can use the cell ID as the index to a hash table or other fast lookup structure. You should be able to use pair. So is this like a tuple, like a okay, as a key to an unordered map? Okay, why not? I mean, okay, So an unordered map. So this would be like if you want to have a super large area, maybe a super large map with a bunch of like empty space, and it's just like we have some areas that has that is populated. Then you don't want to have store everything in like a a grid, like a 2D array that has every possible cell. Instead, you have you just store information about the things that do exist and not about things that doesn't exist. Basically, is that the reason? Like, I would like more context here. Add both objects to the cell they belong to. Now you can easily query all the objects that share the same cell. Add both objects to the cell they belong to. Now you can easily query all objects that share. Oh, I see. So this is for collision, like check. Okay, so this is actually, I'm gonna do this with the quad tree. So what I'm thinking is like I'm gonna have the spatial hash thing for only the tiles, and then I'm gonna have the quad tree as well. That's my idea. So the quad tree is gonna be for more dynamic objects that are moving around, like smaller dynamic things like items, player, enemies, projectiles, things like that. Things that are moving around, while the grid, the spatial hash, is going to be more for just the ground tiles to check if you're colliding against the ground, if you even care about that. So that's the idea. To find all the objects near a particular object, you could query every cell, bordering the target's object cell. Yeah. So to find all the cells, yeah. I mean, I guess what I'm looking for is more this type of stuff, like what kind of data structure could we need to do this? Is there a better way? I guess a 2D array would be super fast though. It's just converting to cell. Yeah, I mean, why not? If we're not gonna have that huge maps, so that should be fine. We could even like pre-allocate a chunk that is like, okay, we're never gonna need more than this amount of data for the grid array, so we could just pre-allocate that and then super quickly. I mean, it could even be a pre-calculated, even if we need to optimize, even building that thing could be pre-optimized. And then we do have dynamic terrain at certain points, but it's not going to be as much as, so it's essentially just certain places where you can attack the wall and the wall breaks. However, those could just be part of the quad tree, to be honest. They don't even need to be part of the tile map. Alright, thank you, Piano. Bye bye. See you later. Good luck in your education. Okay. Insert every object into cell, whenever object moves, calculate new it occupies, take this junction between old and new one. Wait, what the hell? Alternative, insert every object into the cell, its own and all neighboring cells. Whenever an object moves, calculate the new 3x3 grid it occupies. Take the disjunction between the old grid and the new one. These sets might both be empty if the object only moved a little. That is, the new 3x3 grid is identical to the old 3x3 grid. Remove the object from the cells no longer neighbors and it to the new ones. In the worst case, if an object moves more than one tile in a update, if the object moves more than one tile in a second update cycle, you have to do 9 removes and 9 insertions, but that should be rare. In a second update cycle. Okay. So if you're moving extremely fast. Which approach is better will depend on your game, but in general, second approach. Okay. I mean, it's giving me ideas. I guess this is just kind of like a pretty easy solution problem, actually. So, you know, let's just go with what I had in mind at first there. Because given this style of this type of game, I'm just gonna do that. So yeah. So essentially, I'm just gonna add like, I mean, I'm just gonna say grid here. Grid hash whatever. I'm not sure where the hash element comes in or whatever that means, but I guess maybe it means that you're kind of encoding the map into this. So what I'm thinking here, this is going to be like a long-lived thing, is the idea that it's going to have the kind of the data be expanded as necessary and then retaining its capacity. That's the idea. And then once we have that, we can also like populate with different data, or it could also be that we already have like pre-allocated data that is already like in memory, and then we just switch out. So we're basically paying a little bit of memory. Each map has its like grid. I don't think the grid it will take that long to calculate, to be honest. We can start there. We can just start there. So let's just have like a data. So we need an array list of actually, is there like a multi-array list? I think this is more for like structure of arrays. So I don't think that is what we want. I was thinking like a 2D array abstraction. Maybe that doesn't exist. We'll just make one. So this is essentially a bunch of bools. Is it better to use bool or u1s? Also, once you have the hash, what if you have a bunch of vectors? Is it quicker maybe to do? No, it's not quicker. Because is this gonna be like a lookup into the array? We're just calculating the boundaries of the player. And then we get all tiles that we collide with, I guess, maybe. Okay, let's just make an array list of bools, perhaps. Since it's bools, like I'm thinking like, is it more efficient to have like a packed array or whatever? Whatever. Let's just start very naively here. So we'll have this. Let's make an empty. All right. So I want to have like populate or yeah. I guess we have to like provide a pre-calculated 2D array or something. We probably also want to have like width. from own slice. No, I want to basically copy. Well, I guess we can do this. We can provide an allocator. And here we'll do like dupe data. It really takes ownership. Yeah. So we dupe it. Or we just say that, hey, we just take it. We could also just take it. And then there we go. That's probably okay. Let's see. So there we go. Now we want to be able to. So, but essentially, what we want to do is we have a function. I believe. Let's say we have a function that. So for an entity boundary, get all colliding tiles. I think that would be a good thing to do. Like, we want to get all the intersections. The thing though, do we really need, like, let's say the player is touching two tiles at the same time that are both like on the ground, like it's both below the player. So it's like the same level, everything is the same. It's just that they are like the horizontally the same. It's just that the player happens to stand on both, on like one foot on one tile, the other foot on the other tile. We don't really need to have two intersections for that. We really just need one, essentially, for that. So that's the thing as well. Like, I guess it's not gonna be a huge deal though. But anyway, so for an entity boundary, get all colliding tiles. Yeah. Get intersections of all colliding tiles. I think because this will kind of make it so that it adheres to the already existing like kind of interface that we already have for things. Now I'm thinking like, how can we optimize based on the fact that we want to check for a bunch of entities? I mean, do we need to do this for every entity? All the time? I guess only if they update the position. Otherwise, we don't really care. Okay, let's just start with a naive approach. We can do some culling later maybe, but let's just start with a naive approach of just checking all the things. So we want to have one function for checking, I guess, one entity. So get intersections. So we got like, we need like entity boundary. Actually, it's just, we just want to pass an ABB. And this will give us a list of intersections. It's an intersection with what other entity, I guess, is the idea. But I don't, these are not entities, so that's the thing. These are simply going to be, well, I think, I mean, it's gonna be like an AABB actually. And that does not really adhere to the thing we already have, but yeah, because the ground are not gonna be, they're not gonna have like rigid bodies anymore. Yeah, so we just get back a bunch of, I guess, a bunch of rectangles like this. Maybe that's what you could do with the grid hash, is maybe we can have like an optimized, somehow like optimized, like maybe like an R tree. Like let the because the tiles right now are, no, that's bad. That's bad. I don't know. Okay, let's just do it like this. Okay, so how do we do this? So what we want to do is we want to find all the boundary points of this ABB, turn it into grid coordinates, find corners of ABB, turn them into grid coordinates, check all tiles within those coordinates. So find corners of ABB. We already, you know, it's already part of the thing. We have like top left, top right, bottom left, bottom right. So we already have all those very easily. We need to turn them into grid coordinates and then kind of have like an algorithm that goes through all the tiles of the thing. So I guess what we could have is we could have a, we could do like a nested loop or something. So we'll do like start is gonna be top left, So this will be 2 grid coordinates. And this would give us a vector. Wait. Grid. Actually. What do we want? It's essentially just a U32 or something like that. Or I mean, U size is probably better. It's easier to work with the loops. And essentially it's just going to be like V divided by, oh yeah, we need like a conversion. Cell size. Man, I wish there was a way to have kind of like extension methods or traits or whatever, so that you could just say .0. It's gonna be hard though. It's like you have a function, maybe you can specially mark them, but have a function that is supposed to be just extending the interface of a type. Now this is like a vector, so it actually can't have any functions. That's the thing. Like you cannot, like, since it's a vector type, it can't have any functions. Like if it was a struct or a union or an enum, it can have like member functions, but it's a vector, so it can't. It's the same with slices and arrays and stuff like that. So you can't actually do like just .0. You have to have like this other type that has the 0. Well, actually it's not a function, so but it would be really cool if we could do something like this. However, it kind of goes against a little bit how Zig like imports work and all that, because this would be defined over here, which is like in another place than where vector is. Alternatively, allow member functions for vectors or any arbitrary type, maybe. I don't know. That would be kind of cool. But yeah, in the meantime, we can do this, so it's not really that much big of a deal. Okay. Return V over size. And then we need to floor that. And we also do like to int so that converts it to an integer. Okay, so that gives us the grid coordinates of the thing. Now, actually, this could be negative. I think this is like F32, so it can be negative. And if it's negative, I guess it's like always going to be outside of the grid. So how do we deal with that? Actually, also the position is actually, it's oftentimes negative because it's like the center of the map is actually 0, 0. Which is maybe wrong now. Man. Yeah, the positions are all messed up now. I guess we could just translate. We could translate it, but it could still be negative though. The problem then is like we need an offset then as well. So offset cell size is not gonna change, but oops. All right. So it's okay. So then it's gonna be like negative offset. Wait, no. Add offset. Maybe we need to change this into I32 then. Or we calculate this first, check if it's negative, then we return like a null. Because if it's negative, it's not actually in the grid. Why is that unknown type? We know it's a vector. Okay, whatever. Vx translator is less than 0 or y is less than 0. We return no. Now we know that it's positive. We floor it, divide it. No, we divide it by the cell size. We floor it. We convert it to an int. Actually, this was use size. Right? Now, Cool. So now we have the grid coordinates. Whoops. And why is this still like unknown type? Okay, anyway. Start there, yes. So that's the start, and I guess we only need like start and end, to be honest. Top left, bottom right. We start at top left, we go through like, I guess like line by line. So if you have like a boundary that's like this, then this would be the start, this is the end. And so essentially start here, check, is this solid or not? Yes, no. Is this solid or not? Yes, no. Is this solid or not? Yes, no. At here, we have to move down here. Solid or not? Yes, no, and so on and so on. Until we kind of find something that is solid, maybe. We can potentially find multiple things that are solid. Probably never gonna look like this, because then we've kind of warped into the ground somehow. But probably something like this is probably feasible. Have a bunch of things down here. Report all of those as intersections. So we also need to create this intersection list. So actually, let's add an allocator. We will create a list and we could pre-allocate whatever, it doesn't matter. And then in the end we simply return sections to on slice. Alright. So I think what we can do a nested loop. So we'll do like from start dot, no, from, oh yeah, actually this could be null. So if any of these are null, I mean, okay, if both are null, wait, do we even need to do that? Maybe we clamp instead. No, because both can be outside, and then it's. If both are outside, we don't ever collide. But one can be outside and one can be inside at some stage. Like even if one of these are negative, the other one could be positive, which means it's actually... Well, actually the point is not in the grid, to be honest. But it could mean that the other point is in the grid, though. Like if this is outside, if this, let's say this that over here is like the boundary of the level. So this point is outside, this point is also outside. However, the boundary of the entity actually collides here. So I guess what we could do, let's change this to like eye size. We don't do this, we always have a coordinate. And the problem is that Zig for loops, they can only work with like they can only work with unsigned integers, I think. Wait, can you do this? See, it's an unsigned. So this won't even work. Shouldn't this be like a compiler error or something? Wow. This is gonna be like a runtime error, I think. This is a unsigned. Okay. We have to clamp. Lower is 0, upper is width. Actually, I mean, we could just convert it. Couldn't we just convert it to... Because essentially we're kind of moving S over here. So that's fine. E is moved over here. Yeah. And at the other end, we also need to do the same thing. So like if we have this, wait, no, because then we have to have S over here. Wait, S is always there. I guess, okay, this here, yeah. So now S is like negative though. It moves down there. Is there a scenario where... But E is more... Now EX... Right, so now EX is more than this. So E would be snapped back there. And S would be snapped back there. So now Y is negative. EX is more than the width. E is... Actually here, Y is more than that. It snaps back up. So start X can only be negative. Start Y can only be negative. E can only be like more. Like if E is if E is negative, then we are actually like way outside, right? So actually, S only can, or S does, we only need to like clamp it to 0. So actually, we just need to check for max here. Max 0. X start. But actually, you know what? We could just max 0 here. See, that also works. This one though, this is like min. So this will never be negative. If it's negative, it's like way outside. Then we min that. And this would be the boundary maximum. So this would be like width. Sure, let's also have height. Actually, let's just have like grid size. The problem, this is not grid core though. This is actually eye size now. God damn it. Can it be coerced here? No, it can't, because this is well, I'm not sure how this works actually. Okay, but essentially, if let's say this all works out, now everything is snapped into the boundary. So now we just need to loop through the things. So we'll have like the X here is like the X of start to the X of end. Plus 1. That's X. And then we have Y to the Y of end plus 1. I believe it should be plus 1. Because otherwise, if both are 0, it doesn't actually check anything. Hola, cool guy. What's up? I actually have to go soon. I have like 5 minutes or something left. Unfortunately, but I guess I also need to eat something. Haven't really eaten any breakfast today either. All right. Let's see. Okay, so I guess it's like if, you know, it. So it's like if grid coordinate is true, create intersection. check coordinate, then intersections append right, and now is the question how this is going to be calculated, because we have a couple of things in here that we need to populate that we don't get because the LSP is not working correctly. But it's essentially, I think it's like entry, yeah. Entry is the ABB of the tile in question, and so to AABB, I guess we can have the coordinate there. Let's do it like this. It's going to be easier to work with later. So that's the entry. And then we have like depth, I believe. And axis. New game today. Well, it's not really new, but it's like I haven't worked on it for a while. I'm doing fine. How are you? When launching your own games, please make it playable on all devices too. Well, I am working on optimizing it, so I can show you here. Like, let me show you. I'm not sure if you've seen this before, but essentially this is the game here. I'm running a little bit of test here, so if I open, so this chest is already open, I need to remove my save file. But essentially, yeah, it's a 2D side-scrolling metroidvania game. You fight monsters, bosses, find upgrades, items, do quests, stuff like that. And yeah, I mean, it's a very simple game. It's like a, kind of like a 8-bit style old type game. So there's no excuse if it's not gonna be running good on like old devices. However, I'm not sure. It's probably not gonna run. You're probably not gonna play it on a phone. You're gonna have to have a controller to play it. Although I guess some phones work with controllers, but yeah. Anyway, that's the idea. And right now I'm actually working on improving the collision system so it doesn't like lag so much when we do the thing. So if I remove this here and we'll open up the thing and we open this up, it starts to lag a little bit. So that's what I'm trying to do. So there we go. You're drinking beer because you're sad? Oh, what happened? Sorry to hear that. Is it something bad? Right. Now, this thing, I mean, I guess the axis, I mean, it's just gonna be, I think it's, I'm not even sure if we use this, to be honest. Maybe we are. I mean, we could use it in the resolution. The thing about the resolution, though, is that it uses 2 bodies. So we would, well, we could write a special case for this, though. It's essentially just gonna push whatever is going into the tile back in the direction it came from. All your friends got married? Are you the only one that doesn't have a girlfriend, or? That sounds like very implausible, but okay. Like, how old are you? And also, it's that classic case where you see a person that has like a nice car, and you get jealous, and you want to have the same car. Or, well, not the same, but you know what I mean. 24. I mean, I don't know. I think that's kind of young to get married, but that's just me. You know, people like I saw people like when I grew up. I saw like people when they were like 18 and got like kids. I mean, sure, do whatever you want, but you know, you have to be aware of, you're basically, how should I say this, like your own, like if you had like dreams of having a career and stuff like that, it's like if you get a kid when you're 18, it's like you're basically throwing that away, basically. And how would you economically support a kid when you're like 18? Like, you don't really know what you're getting yourself into, is what I'm trying to say. Like, do whatever you want, but I guess, you know, things can happen by mistake as well, but yeah, you know what I mean. They are 22, they got married. Yeah, okay, well, you know, I had a friend that got married a couple of times. Yeah, you can get kids even if you use protection. But anyway, what the hell am I trying to say? I don't know. I'm not a life coach. I'm just saying, like, that it's young. It's like, how many relationships like have you had at that point? How do you know that you're gonna last your whole life? Like, you don't know. Like, I just I don't know. The whole concept of marriage is kind of weird to me as well. I don't know. Maybe I'm the weird one, though. I'm probably the weird one. I mean, it's not the concept, maybe. It's more like, yeah. Especially when you're that young, because you don't have that much experience. But yeah, I'm not saying that your friends all gonna get divorced, but I think the chances or the risks are higher at that point. Anyway, I don't want to be negative though. Okay. But I mean, I can understand also, like, if you have a bunch of friends and all of a sudden they get girlfriends, they get married, and then you don't hang out anymore. That's pretty shitty. Like, do you hang around? Do you hang out with them anything, or still, or are they just focusing on like their family and stuff? I don't want to get married, but girlfriends need. Yeah, I mean, great. Then you could work on that. I don't know what to tell you there. I'm not a dating coach. I guess, yeah, I can all tell you, like, I hope it works out for you. Alright, so... Okay, we'll not get to getting this working today. I actually have to go now. You should give some tips. Well, as I said, I'm not a dating coach, so you need to look for something else. I am probably the worst person to look for tips. So, and you know, I have a girlfriend and a kid, but you know, that doesn't mean that I can give you tips. So, but yeah. But yeah, I have to go now, so we're gonna have to pick this up later. Probably tomorrow, we'll see. But yeah, thank you very much for watching. I will see you later.